You said it, man. 1977 was a really happening year. I'm just glad I got to see those bell bottoms for myself. Hey, you got something there. Dear Tim and Moby, I heard that if someone was on a spaceship traveling close to the speed of light, time would slow down. Is that true? From Noah. Interesting question. First of all, no one can travel anywhere near the speed of light. The speed of light is the universe's ultimate speed limit, and it's about 300 million meters per second. It would take an infinite amount of energy to make even the tiniest bit of matter go that fast, so you're asking about a hypothetical situation. It is true, though, that some weird stuff would happen if you could. Let's show them. Space trip. Okay, let's say you and I waved goodbye to our friends on Earth before taking a ride on a spaceship to a nearby star. Ready? I sure hope you know how to drive this thing. Engage. Hey Moby, take it into overdrive. We'll need to go as close to the speed of light as you can get. Well, here we are at... wait, what star is this, Moby? Here we are at Minui Relativa, and boy, is the view spectacular. Let's get a picture. Right then, I'm ready to go back, are you? Okay, get ready to be freaked out. Weird, isn't it? See, the faster you're going relative to a certain frame of reference, the slower time goes for you. Here on Earth, Cassie, Rita, and Gary experienced the passing of 35 years while we were gone. But because we were traveling at close to the speed of light, Moby and I only experienced the passage of 5 years. So, to answer Noah's question, yes, it really would happen like that if we could travel that fast. Well, the effect has been demonstrated at slower speeds too. Clocks on airplanes have been shown to tick a teeny bit slower than clocks on the ground. It all has to do with relativity. Relativity is a scientific theory that explains how things like motion, time, space, and gravity work. It was developed in the early 20th century by a guy you might have heard of, Albert Einstein. Before Einstein, the universe's forces were best described by the English physicist Isaac Newton. Newton's explanations for things like gravity worked perfectly well most of the time. But they fell short when trying to explain very large and very distant objects. So, being the genius that he was, Einstein came up with a better explanation, and that turned into his theories of relativity. Yeah, theories. There are actually two types of relativity, and they describe different things about the universe. The first one, special relativity, deals with the relationships between speed, time, and distance. To start with, special relativity says that light always travels at the same speed, the speed of light. But also, Einstein found that it's impossible to tell whether you're moving unless you can determine that you're moving relative to some other object. Because of that, time and distance can't be absolute. They can change, like we saw with the spaceship example. Right, special relativity also gave us probably the most famous equation of all time, E equals mc squared. In a nutshell, it means that matter and energy are the same thing, which is one of the most important and far-reaching ideas ever thought up. You can learn more about it in our other features. Anyway, the other type of relativity is called general relativity. When Einstein wrote about this, he was trying to describe the force of gravity. One big discovery of his was that gravity is equivalent to acceleration. So, the force you feel when you're lifted in an elevator feels the same as the force of gravity pushing you down. But more importantly, general relativity says that gravity can affect time and space. See, space and time are interrelated. They can be thought of as a four-dimensional thing called space-time. In general relativity, massive objects bend the fabric of space-time around them. This idea led physicists to start understanding things like the existence of black holes and the origin and fate of the universe. Yeah, it'll blow your mind if you think about it for a while. Take that thing off, you look ridiculous. Oh, right.